Good afternoon, everyone, and welcome back to our day two workshop on GWAS. I think we can straight away start the session. Over to you, sir.
Okay. Good evening, everybody. Please, I hope that everybody has got the files and you have uploaded in your system. So I hope you have done that already. So you can start with the Art Studio. If you have any doubts, you can let me know. Yes, madam. Please tell me. So in this particular work, we will be using SNP Stats. So SNP Stats is a bioconductor package. Okay, so before that, what you need to do is you will need first set the working directory, choose directory. In this particular, wherever you have saved the files which was mailed and WhatsApp to you, just you need to select the particular directory. So this is the first step before you start any art project or art studio project. So I have already set my path. Anybody is having any doubt, you can just let me know before I start it further. If you have any doubts, you can put it in the chat box or you can unmute and speak, not a problem. Anyway, the codes I will be sharing by the day and today, the complete codes along with the PPT. I will be sharing the code to you all. But before that, I will be just discussing the codes to you because towards the end, some of the codes it will take a lot of time for execution. So I will not wait for that. I will just explain you the code, and you can explain. That is the last part that I need to do it. So has everybody done with this part? So I hope everybody has set up their working directory. Just you can put a message in the chat box as yes. Then I will be moving ahead. Okay, yeah. Who all are there in this particular? Yeah. Sakshi, Santosh, Sushmita, and others. Are you able to do this part? Did you set up your working directory? Did you set up the working directory? That is the first step in R. So I have set up my working directory. This is the where I have loaded the files. So you need to the file which I had sent yesterday. And in the mail, what I have done is I had taken all the files and it in a single zipped file. So just you need to set the working directory to where the files are there. That is your working directory. I hope it is done. Sakshi, Shushmita, is it done? What is the data or genomics? No, for you, I have given it is a data file. So just you have to unzip and there are two folders. There will be one folder actually. One moment. Okay, 1 minute. I will just resend this. There is, yeah. Okay, 1 moment. I will just resend this. One moment, please. Yeah, just now I have sent you one folder. Just you, that's all. You download it and unzip it. That's all. No need to do anything. Just download it. You can just check in your mail. I have just sent the file, and you can download it and you can install it. Even let me see if I can put it here also. Yeah. So it is getting uploaded. It is already sent to your mail. Just you can take this file, unzip and put it. This particular files contains everything which is needed for the work. Okay, now if this is done for you, I just got a message. What is the message I got? Sir, I am not able to install SNP stats. Just follow the code which I have sent in the chat box. Because it is SNP stats, it is stats is capital S. It says cannot open the URL. In the mail also, in the mail I have sent you the same folder. Or here also you can download it. Mail also I sent you, and this one also. It is shared to all actually. Others, if you are able to download it, I shared in the chat box as well as in the mail just now, the genomics zip. So once you have done that, just you can set your working directory. So I have put it here actually. So this is the file for me. So that's it, you have to do it. And you have to click on open. Is it fine with all? Is it fine with all? This till this part? And you have to, once you are selecting it, you have to click open. And before installing SNP stats, you need to install bioconductor. That is essential. Without that, it will not run. So, bioconductor is a hub for bioinformatics softwares. This is a part of your CRAN, that is bioconductor, which contains all the required data. Sorry, all the required softwares, and the along with the software, it also contains the R codes for any bioinformatics related works. So just you have to select it in this manner. You see here in the second line, there will be a space. Just run it. It will just select it in this manner and run it. It will run. So there is one question asked, update some, all or none. You can just give your A. A means all. All, some, none. So ASN, all, some, and none. So it will get updated. After that, you need to download the library. Why it is not installing for you? Unable to access index for repository. Cannot open. Unable to index. Okay. Bioconductor. Is it your old version of RStudio or R? I think your R and RStudio version is 3.18. Now I am able to install for me. You are telling BioC version SNP stats are not available for bioconductor. Others are also facing the same problem. Others are also facing the same problem. Mine is bioconductor version 3.19. My R version is 4.4.1. Just check it out. What is your R version? R version 4.4.1. Okay. So I that is the problem with the version. So that is the I think because because BioSim manager it will support. If it is supporting for me, if it should also support for you, I feel. Okay. After that, you can just take this code, load conversion table. If the conversion table is already mailed to you, it is already in this particular folder. So just execute it. If it is, see, I got a message that the directory is not there. So just I have to change the directory. It will take. So for you, it will not be a problem. For you, it will take it. So it is loading. So for you, I have given everything in the single folder. So you can, it will get access to you. So you can see the conversion table is loaded with large character. How much it is? 26 lakhs elements. Almost. Yeah, 26, almost 26 lakhs elements. So is it fine? The Niharika, yes, Santosh, yes. Smita, bioinfo is shit. Bioinfo? Who is this bioinfo? I don't know who is this person. Bioinfo. I want to know if it is you are able to you're able to follow these codes. Initial codes I will just tell you so that later codes I can just explain it to you. So just you can let me know the initial codes are working for you. Yes. Others, Niharika Sharma. So are you able to install? Are you able to install? Because initial things, if you are able to do it, others will happen automatically. Then who else is there? Shakshi, Santosh, Savita, Sushmita, Vaishnavi. This person, Vakil P. Who is this person? I am not able to understand. So just I want to know if it is so far you are able to do it. Okay. Others, Sakshi, Santosh, Shavita, Sushmita, Vaishnavi, Niharika. Last person, Vakil P. Please let me know if it is done, then I will proceed further. Okay. So, okay, before starting, I just wanted, though already I started it, this is the art studio. In this, I hope you know these are the four parts. First one is this art script, art console. This is the environment, and this is mainly for the visualization. So the art studio has the four parts. So in the whatever the scripts you are typing it there, you can just save it. Okay, you can just save it. This is the advantage for the R script. Console is for the execution. So even you can type it here and you can type here. So in the R console, if you are typing it, it is not possible to save. Whereas if you are typing in R script, then you can. It is easy for you to. So R notebook also you can call it as, and you can get it. So R script, if you are clicking it here, you will be getting the new one. So whatever you are typing it here, it is easy for you to save it. So this is the advantage, but if you are typing it here, it is not possible to save. So it is always my advice that you type it in the top. So if you are typing in the top here, then it will be working fine. Okay, so let us move on. So first one, we are setting the path. So for me, I have set the path as public genomics. For you, it will be I have given only the genomics. So you just have to click it like genomics, and the one I will just send it for you. So for you, it will be just genomics because you don't have this public. It is only for me. So remember, this is the path. So paste path and you are typing it. So and it is getting created. So you are just pasting the path and you are reading the path as it is. So and somebody had messaged in the group from where to get the files. So I had told initially that there is a database. I will just show it in the WhatsApp group. There was a message. I will just show it for you for in the time being. Okay, one moment. So this is the one standard website where from where you can download the files. That is the whichever is needed for your work. So this is the International HapMap project. So from where you can get the files. Okay. So this is all HapMap files. Everything will be there related to your project. But as I told in this particular this one website or database, your related data will be there or not, it depends. Okay, usually it is always better that you can take the data from some researchers and you do it. So that will increase the collaboration for the projects and all you can do with this particular website. Okay, now second part is you have bed, beam, and FAM. So just I wanted to show you the file format, because it is for this. If I open it, it will not be getting displayed. So I will just show you the file format. One moment. One moment. Yeah. So these are the P-Link files. I hope my screen is visible to all.
Yes, sir.
Yeah. So you have this pet map fam. Okay. This is how the general file will be looking. Okay. So for GWAS, the files are very big. It is for you. It will be very difficult to understand. But these are the simple things I had made for you. This tutorial also I will be sharing it across to you. So pet files will be like this: map files, FAM, bed, and all these abbreviations also I will be sending it to you. So that for you it will be easy to understand what are all these. This is all given here. So you can see that family ID, individual ID, parental ID, and so on. So this is how a sample file, though it is written as P-Link, it is standard file for the GWAS experiment. Even tomorrow, Harshit will be taking the class for this P-Link, this one software in R. So wherein he will also be showing this one. So these are the general files, and not only P-Link, SNP stats, many are there. You can use it. And here, as I told you last class, the SNP will be like RS1, RS2, it will be there. So don't think that RS1 is there. Actually, RS1 is just a demo file. It just contains RS, and then it will be, there will be some numbers. Okay, just it is for you to understand. Okay, and the files which we have taken for this particular work, you can see GWAS Indian FAM, for GWAS Indian FAM, Indian BEAM, and Indian. So we have taken three files: FAM, bin, and bed. Again, Chinese FAM, bin, and bed. Malay FAM, bin, and bed. And these are the two files which is already there. And further, we have this. These are the three text file which contains the data. Okay, so this particular file which is given to you, it will be working out with most of the GWAS experiment which is given. Okay, and other things you can always depend on this HapMap project wherein you can get it. Okay, let us move on. So I am just telling you all this overviews. In the later part, I will just tell you about the codes and all, so that it doesn't become difficult for you to understand this part. Because executing the codes are easy, but understanding all these minute things will be little tricky. Okay, so let us move on. So far, any doubts, you can let me know. I hope everybody so far has is along with me that they have installed the bioconductor SNP stats, and conversion table is loaded for everybody. So I think this part is done for everybody. Okay, so let us move on. So here what we are doing is we are giving the path, and for each and everything that is bed, beam and fam, you are storing it in path 1, path 2 and path 3. So the whatever is getting executed here, the output will be coming here. So if you want to visualize this, just you have to click it here, you will see to it. There is nothing hard fast rule that how to see this. You need to click over here. Now I am not able to click it since the code is running. Once the code will stop running, if I click here, you will be able to visualize what is this. So you can try it at your home on your own, because I am also running the Zoom in my system. The system will get hanged. So later you can do it, because this is a very big file. So any doubts, please always let me know. You can see there are 3 elements created. So 3 elements are created here. You can see to it, it will come here. So here it will get displayed, because it is not able to display because it is very big. That is the problem. Okay, so next one we will do it. Anyway, don't worry on the codes. Even if you are missing it, I will mail you all the codes. Don't worry on that. Okay. So far what I have done is I have created the path for the SNPs. You can already see it is largely, so it will be difficult for you to see to it. So other option is that if you want to see what is in this file, in the R, there is a command by name head. Using the head, you can download it and you can see to it. I think everybody is aware of this head command. So and you can use this head command to see to it what are all this in these files. Okay, so I think this part is done for everybody. We will move ahead. So it is done. And remember, those who are, if anybody is new to R, hash command is just for giving, for it is for the user. So that if at all you want to understand what this particular line or what this particular command is doing it, you can always use the hash symbol. This particular symbol, the whenever the R is seeing encountering this hash symbol, it is understood that the R will not be reading it, and it is only for you to understand. Any doubts, you can always let me know. So this particular we have approx 232 individuals, wherein in the file there are 110 Chinese, 105 Indian and 108 Malayan files are there. A total of approx 25 lakhs SNPs are there in this in the particular uh, file which is given to you. So in this, you are combining all the files in here. So let us run it. So this is executed properly. So here it is checking out in this that different number of columns in the input is detected. This is not allowed. So if at all there is any means it is called as pre-processing step. Pre-processing step is that wherever it will find some irrelevant files, so it will just skip it out. So that is what it is told here. If something different is seen in this particular input, it will just stop it. So so for you it is executed means it is all proper. Then we are merging the three SNPs. You can see that using the hash command I have given here. So in the similar manner, you will be getting all the codes. Only thing is that I will just want that you can just see it, and then if there is any doubts, you can let me know. And at the same time, of course, practice on your own. So here what is given here SNPM, SNPI, and SNPC. Just here you are understanding that SNPM. What is SNPM? This is the first one. It contains the this one Malay population. So SNPN, SNPI is the Indian population, SNPC is the Chinese population. What you are doing is you are combining it. Okay. Now what you are doing is rename the SNPs present in the conversion table into the RS IDs. So do that. So here it will not much time for all these codes. You can do it. Okay, so this is done. Then we are loading the lipid data sets and the match of SNP lipodynamic samples. That is, this is also given in the file towards the end. In the file which I have sent it to you. So here that is the lead drilling, that is the dimension it is given here, the path, that is for me it is saved in this manner. For you it will be saved in a different manner. Sorry, I have to, you need to change the file for here. It will be public or what name I have given, genomics I think. Yeah, genomics file I think I have given you. So just have to change the public to genomics. Okay, 1 minute, I will only do it for you. 1 moment. So here it will be genomics. Let me check what file I had given. Public only I think you were given. It's public only, so no problem. So for file name is no genomics. It is genomics. So it is genomics. The second one also you have to change it to genomics. So all I have changed to genomics and sent to you. Okay. Okay, so it is already loaded for me. For me, it is so. If I'm clicking here, you can see these are the things. Okay, you can check it out. It's a very big file. Okay, so if at all you want to save it, you can see that there is a floppy disk like option, save option. You can just save it; it will get saved. And for you, it will be asking that the path and all. You can save it in the concerned in your own path, whichever you feel like. Okay. So what we have done, we have imported and merged the three lipid data set, which is stored in the TXT format, and we have determined which samples are present in the both the SNPs and the lipid data. Okay. So then, so let us move with the next code. So here it is all merged. So we are creating a list with this gen data, which will store all the merged SNP data. Okay, that we are doing it. If everybody is along with me, please let me know. Are all able to do this? Anybody who is not in, like not able to do it, let me know. So we are creating the data frame. Okay, you can see all the SNP genotypes are merged with the names M, I, and C, wherein M is for the Malay, I is for the Indian, and C is the country. C is the China, and it is for the country. It is David. So it is the data frame is created. So we are checking the matching samples in the row names and the genotypes. So it is executed. If you want, you can check it out. The lib data is here. So it is merged for all. You can see here there are approx 50 columns. So now we are combining the SNPs with the lipid profiles. Okay. So now our file is ready. And check the gen data. I don't know, it will get displayed. No, it is large list. Whichever is large list, it is difficult for you to see it. So you can always use the head command and you can view it. Okay. So now we are our files are we need to save them. It will take some time. It will take some time. This will again, it will, this will be the input for the next, for the subsetting codes. So it will take some time. So this pheno data, it is going, means it is writing it. So this particular file, pheno genome map, genome map, we will be, this is our output file from this one, which based on which we will be checking the principal component analysis file and the further Wilber's algorithm, we will be doing it, and Manhattan plot based on this particular file. So it will take some time. I hope so far any doubts from any person? Niharika, Paddy, Sakshi, Santosh, Shavita, Sushmita, Vaishnavi. So far any doubts? So far any doubts? Anyway, all the codes will be given to you along with explanation. So you can practice it, and you can use the same codes with the different files and check it out if these are all working. Mainly what you need from here is the bed, BAM and FIM files. Okay, okay, sure. Okay, so it will take some time. So you can see it is slowly it is getting right. Even for me, I am using the Zoom, so it will take more time. It has executed. So now we are clearing the memory. So just it will because other things it will go off. Only we need this genome map data, and before that we need to install this code, because this will not get executed genable, so don't worry on that. Anyway, genable I will remove it and I will send to you only, so that you will tell that it is not coming. Genable I will remove, it will not get installed. Okay, so I will just get an error for this genable. It will not, otherwise it is fine. So genable package is not there. Apart from that, everything is fine. Okay. So now the GWAS function R, this is already given to you, and this Finogeno R data just now we saved it. So these are the two files which you will be needing for the next for the upcoming course. Okay. So it will take some time for taking it. Yeah, so it has executed. So it has created the S&P stats is having 7 lakh 95,000 observation of the 9 variables, and we have called this S&P stats already because from that you are getting this column summary. So column summary you can check it out. So from the gen data of the S&P. So but it is difficult, as I told you, it will not get displayed. And then with the gen data you are performing the next steps. Okay. So here you are doing the Hardy Weinberg atrocity file. It is getting it. Just check it out if this is getting executed for you all. So here the input file is your gen data for only for the SNP. So here you have the processed, and it is only the SNPs which you are getting is taking. So it is performing the Schrodinger's algorithm here. Yeah, it is done. So you can just check the result. Again, it is a large file, difficult to see. Yeah, nothing is visible. Okay, yeah. So you have the tree list and raw files. You can check it out here. So this is the minimum thing which you will be able to see it. Okay. So from the gene data file, you are proceeding ahead with the principal component. Okay. Here you are specifying the ID to kin1, and here you are converting the bed to the GDS file, and these are all the parameters which is created initially So let us see, this file will be, it will take time. It will take time. The function SNP GDS bet to GDS creates the GDS necessary for this analysis, that is the PC analysis, to determine the kinship coefficient between the pairs of the sample. We are using or creating the correlated SNPs, and for this we are giving the ranges, that is ID is 0.2 and kin 0.1. It will take time. This one will take time. So you are having around 25,000, sorry, 25 lakhs, 27,458 SNPs. Okay, it is done. It is done. Okay. So you are getting the genome file from this MyGDS, which is already created by you. You are getting the GD IDs. You are giving the name of the sample ID, and the GDS ID you are giving it -1 with the GD IDs, and you are and you are giving the genome file with the name sample ID, and you are in the genome sample IDs, you are taking the row names or that from the gene data file, only the SNP. Okay, I think that is done. Okay. Okay. So here it is linkage disequilibrium. You are trying it here. Yes, the scripts I will be anyway. I have sent it to you. Further, I will be sending the all the scripts. Okay, so this one will take time till 12 hours here, this particular step. So this result we will be able to see only tomorrow. Okay, So anyway, I will be sharing the script now to you in the mail. You can execute it, and if you are coming up with the doubts, you can let me know tomorrow, because here it will take more than 12 hours for executions. This part. The codes are already shared in the chat box, as well as I will be mailing you now only.
So we have a question from Niharika.
Yeah, I've seen it. One moment.
Yes.
I am sending the files actually, because it will take much time for getting processed. So I am preparing the files for them. So then I will be taking up the question. Give me some time.
Yes, sir.
So let us take the question in the meantime. Okay, one moment. Is there any other database or websites available to retrieve raw genomic data for GWAS studies? Yeah, there is in from the EBI also. You can get it, as well as Geno 3D. You can get the data. Then Ensemble Geo dataset and all, you can get it. Okay, then please send your code is already sent to you. And okay, and yeah, what kind of sample that was it? First only I have told you what kind of sample we had taken. Okay, and regarding this question, conversion, what is it called? Conversion table, it helps in converting from the raw files to the genomic data files. That is what it is for the conversion file. Okay, that is the what is that is the preloaded file only for this particular work. Okay. Okay, and anything else I need to know how that is done. How that is done. Okay, I will tell. That is that contains the script for this, which is I think already I have sent you the script. Okay, in that you can get the information, and also the complete things in the documentation you will be getting it. Okay.
Hello, Dr. Bakchi.
Yes.
Yeah, I think the main thing that I couldn't follow is what kind of input files exactly needed. Like from the raw data set, how do you input them as a conversion table? That's my main confusion. And what type of the phenotypic or those files. So I think that's why I said that I'll come back with the queries tomorrow, because I need to see each of the input file and understand how that is processed with the scripts that you have provided. Then only I would be able to use them with any other data set,
Okay.
because
Great.
this is a ready-made thing that you gave us, right?
Yeah. It is ready-made
Yeah.
thing. I
So
gave it for so that you can
for the
also practice it.
yeah,
Yes.
yeah. So I'll try to do
Along with the
this.
tutorials is given to you.
Yeah.
Hmm.
Yeah,
Hmm.
I'll try to do this myself, and
Hmm.
please allow me some time so
Yeah.
that I can come back to you tomorrow
Hmm.
with the things that I am confused at.
Yeah, sure.
Thank
Sure.
you.
Thank you. Okay, so we will be ending here. All the codes I have shared to you, because it will take some time. It will take almost 12 hours or more for this particular code to get executed, which is already given to you, shared with you in the both chat box as well as in your mail. Okay, so here I will be ending it here, and you can practice it and let me know what you are getting it. Okay. And tomorrow at the same time we will join. Okay, then see you. Okay, so Anusha, you can end the meeting for today. And if there is any things, you all can message in the chat box, or also you can mail us. Thank you.
Thank you, sir.
Yeah, thank you.
Thank you, everybody, for joining us today. Tomorrow we shall see you online at same time. Thank you all.